Greetings everybody. I go by the name Banile Sondiaza, a final year BEng Tech student at Central University of Technology. I'm here to present my project, which is a smart dispenser and ventilation system. Currently this project is at the prototype stage, hence you see wires and the breadboards around. We don't have enclosures at this stage. This project is designed to help address daily challenges that we face at workplace, at school, at your hospital, public libraries. So I'll show you around. So here I'm having 3 sensors. The first one is IR sensor. IR sensor is used to detect motion or the presence of an object. When an object comes in front of the IR sensor, it reflects infrared light back to the receiver, allowing the system to detect that something is there. In this project, the IR sensor plays a key role in activating the water dispense system when it detects the cup or something that will be placed in front of my water dispenser system. So let's go to the second sensor, which is ultrasonic sensor. So I will use ultrasonic sensor to measure the water level. I'll measure the water level. So IR sensor works by sending sound waves. So it works by sending out ultrasonic sound waves, measuring the time it takes for the waves to bounce back after hitting the water surface. Using time, the sensor calculates the distance between itself and the water. In this project, this ultrasonic sensor helps monitor the water level real time. For example, if measured distance becomes too small, it means the tank is nearly empty. A buzzer will be triggered. So on my system, I've set it that if ever it is around 17 centimeter, the buzzer should be triggered, but then I'll show you shortly on my code. And the third and the last sensor, which is DHT level. So this sensor, which is DHT level, is used to measure temperature and humidity. In this project, I'm focusing on the temperature reading. The sensor detects the surrounding air temperature and sends that data to the Arduino. In this system, the DHT level plays a critical role in controlling the ventilation. So my ventilation here, I'm using a fan which is 9 volts. So when the temperature rises above a certain threshold, let's say on this system, mine it's 22 degrees Celsius. So the Arduino activates the fan through a relay, this relay module, to help cool the environment. The current temperature reading is also displayed on this LCD. So currently the temperature is 15.70 degrees Celsius. So users can monitor it in real time. Also, I'm having 2 relay modules. Like how I introduced my system, I said it's water dispenser and ventilation system. So I want these systems to work independently. Hence, I'm using 2 relay modules. This one is for ventilation to control the fan, and that one is for dispenser. It will control the pump. I'm having a submersible pump here. It's 5 volts. It will help me to pump when the IR sensor senses something, a cup, this pump should be activated. And here I'm having a push button. So this push button, it should trigger my servo motor. So once I press there, the servo motor should open, and the servo motor acts as a lead. So this system will be covered. So let's say you wanna refill, you trigger the servo motor by pressing the button, it opens, you refill, then it closes. So shortly, let's go to my code here. So now it's time that I demonstrate my project. I'm gonna start by using this container. It will act as my cup. I'm expecting when I place it in front of this IR sensor, my submersible pump will pump water into this container. So let's see. So the water was pumped into the container. So the next step is to see what's gonna happen if ever we pump water. It will be here. I'm having 14. So let's go to 17 centimeters. Let's pump more water. When you pump more water, it shows that your tank is almost empty. The buzzer is triggered. Let's press our push button. It opens. Let's refill our tank. We refilled our tank. So here's my code, my program. Here I'm using Arduino IDE. So let me show you the distance. So here the buzzer will be triggered when the ultrasonic sensor detects a distance that is greater than 17 centimeters. Then the temperature will trigger the fan when it is above 22 degrees Celsius. So in this code, I also included the one for ISP or Wi-Fi module to send it to ThinkSpeak. Let's check the serial monitor. The serial monitor to read or print to see that our ESP is working. So now it's time to show you my ThinkSpeak. So here's my ThinkSpeak. The last entry was about 4 hours ago. So here I'm having temperature. This side I'm having water level in centimeter. It's 2 fields. For my ventilation system, I'm about to demonstrate. I'm having DHT level sensor, a relay module which controls my 9 volts fan and external power supply of 9 volts. So for demonstration purposes, I'll be using this gas lighter to show how the DHT level sensor responds to heat. Please don't try this on your own, especially without adult supervision. Fire can be very dangerous. I'm keeping the flame at safe distance and using it briefly. Only raise the temperature around the sensor. No part of the sensor or the components will be directly burned. Safety is the top priority and fire should be handled responsibly. So let's see my temperature. So the temperature, when it is above 22 degrees Celsius, the fan is activated. So now it's around 28, the fan is running. Let's see when it goes down below 22 degrees Celsius, what's going to happen. I've come to an end. Thanks for watching this demonstration of my project. I hope you enjoyed. Until next time, stay innovative.